Hey everybody, Mr. Reeves back with you. And today we're doing a quick review of Module 16, which covers representing proportional relationships. We're going to look at slope as rate of change and slope as unit rate. I'm going to do this pretty quickly. If you need more details, you can go back and watch the videos where I took each one of these on individually. All right, but we're going to kind of hit all of them in one fell swoop, as they say, as a review. All right, so just a reminder, a proportional relationship is a relationship between two sets of quantities or two numbers in which one of them is a constant multiple of the other. And when you write them as ratios, the ratios will always simplify to the same ratio. So if you take a look here, water to vinegar, you can see that the amount of water is always 5 times the amount of vinegar. If I take any of these and I simplify them, I will always get back to that initial one, 5 over 1. All right? And remember, now normally this table is, normally we have x on the top and y on the bottom. This one they happen to put y here and x here. So always make sure you know which is x and which is y. All right, y divided by x gives us k. And remember that k is called the constant of proportionality. Takes a long time to write that word. Constant of proportionality. So k is equal to y divided by x. So in this case, 25 divided by 5, 20 divided by 4, etc. I'm always going to get the same thing. So k is equal to 5. Okay? Now, when we are representing proportional relationships, there are 4 ways that we can represent proportional relationships. Okay? One of those ways is in words, or we often call it the verbal representation. So it tells us Martin mixes a cleaning spray that is 1 part vinegar to 5 parts water. So that is the verbal representation. Now, what the verbal representation doesn't let us know is which is x and which is y, because I know that the water is 5 times the amount of vinegar, but the vinegar is 1/5 the amount of water. So that's why we have to go beyond the verbal, or they have to tell us if they want us to know. Okay? The table actually doesn't let us know either, because when I got to be honest, when I first looked at this, I thought it was x and then y, because that's how we usually have tables. But the graph is the giveaway. If they don't specifically tell you, this is always the x-axis right here, and this is always the y-axis, okay? So now we know that x is the amount of vinegar, right? And y is the amount of water, okay? So you can see on the graph that the amount of water is 5 times the number of vinegar, right? The amount of vinegar. So this first point right here is 1, 5, and then we have 2, 10. So all of these points from the table are on the graph. 3, 15, and then we have 4, 20, and then over here we have 5, 25. And again, y divided by x always equals, in this case, 5. That is our constant of proportionality. Okay, so I said we have 4 ways to represent it. We have words, we have the table, which is right here, okay? We have a graph right here. And then the final way we have is the equation. So if I scroll down here, we will see that right down here we have the equation. And again, you cannot write the equation. In fact, you can't find the constant proportionality unless you know what x and y are. All right? They probably should have told us this way back up at the top. Y is the number of cups of water. X is the amount of vinegar. All right? So our equation is always going to be y equals k times x. So k here was equal to 5. If you want to know the amount of water, you take the amount of vinegar and you multiply it by 5. Okay? 4 ways to represent that proportional relationship. All right, quick example here. We have distance traveled in miles and gas used in gallons. Okay, so you could see right here, if this is a proportional relationship, these ratios all have to be the same. So if I do 100 divided by 5, I'm going to get 20. So this number is always going to be 20 times bigger than that, right? So if I'm going to go the other direction, I'm going to divide by 20. Well, 200 divided by 20 is going to be 10. All right, 15 times 20 is going to be 300. 400 divided by 20 is going to be 20. All right, I'm thinking they want 500 here. What do you think here? 5, 10, 15, 20, 25. Look at that, okay? So this is going up by 5s, and this is going up by 100s. Okay, so let's see if they tell us what they want X and Y to be. Let X be the number of gallons used. Okay, so they're going to make this X, and they're going to make this Y. Again, I just want to warn you, many times in tables, X is first and Y is second. In fact, I'd say most of the time. Remember, K is equal to Y divided by X. So what did we just say? K in this case would be 20, right? So our equation, each ratio we said was equal to 20 over 1. All right. So X was the number of gallons of gas used. Y would be the distance driven. Okay. And the equation would be y is equal to 20x, right? If you want to know y, simply take x and multiply it by 20, right? So if I had 40 here and asked you what would go up here, it would be 800 because I would multiply by 20. All right, that is a quick review of proportional relationships and representing proportional relationships. What about slope? All right. So slope is the rate of change. It's the change in y over the change in x, or sometimes we say the rise over the run. All right, the rise over, let me see if I can get myself a little space here. Run, and remember we use this symbol, change in y over change in x, right? And remember, slope can be positive or slope can be negative. Let me do this real quick. If I have a slope that goes up from left to right, that is a positive. If I have a slope that goes down from left to right, that is a negative. So you can see on this line, this would be a negative slope because it goes down from left to right. So if we take a look at our table, here's our x, here's our y. So if we look at the change between them, that goes down by 2, that goes down by 2, that goes down by 2. What's this one doing? It's going up by 3. So as you can see right here, our slope, all right, well, the way I would do it is I would just take any of these and say it's down 2 over 3. My change in y is that negative 2, and my change in x is positive 3. All right, they picked 2 points and they found it by subtracting. Remember, for finding slope, you can use any 2 points on the line. So that's finding slope from the table, the change in y over the change in x. All right, if it is a proportional relationship, those will always be the same. It's going to be constant. By the way, if it's a proportional relationship, it will always be a straight line that goes through 0, 0. So when you look at the graph, if you see a straight line that goes through 0, 0, it's a proportional relationship. Okay, change in y over change in x, getting the slope from the table. If you want to get the slope from the line itself, you can pick any point on the line that you want to. And again, my advice to you is pick a point that is on the line and on the grid. They use that point there and that point there. It looks to me like I could also use this point, right? I could also use that point. We could use any of those points there. And you simply say, what is the change from that one point to the next point, all right? And so if I did this one, I go down and over. I like going this direction when I know it's negative. All right, I know if you look at their arrows, they went up and they went left, but I like to go down and right, and I say, okay, my change is down 2 and right 3, right? Down 2 and right 3. You could see they went up, right? They went up 1, 2, 3, 4, 5, 6. They went up 6 and they went back 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So theirs was positive 6 over negative 9. See that right there? But what does that simplify to? It simplifies to the same thing. All right? So that's different ways, a quick review of finding slope from the table, change in y over change in x. And again, you can use any 2 points. If I had gone all the way from there to there, that would have gone down 6. And if I had gone all the way from there to there, that would have gone up 9. And again, down 6 and up 9 is going to give me that same result. All right, great thing about slope. You can use lots of different points. All right, and finally, last thing here, slope as unit rate. Okay, so slope also gives us the unit rate, and right now we're working with only proportional relationships. So again, if you take a look at this line, you can recognize it's a proportional relationship because it's a straight line that goes through 0, 0. And if you want to know the slope of the line, you could pick any 2 points you want to, but I'm looking for points that are on the line and on the grid. All right, so do you see how these points are good ones to pick? Right there. So if I pick those points and I do what I just did on the previous example, I go up 2 and over 1. Up 2, right? Over 1. Up 2, over 1 that way. So my slope would be 2 over 1. But if we look at what that means, this is miles and this is time. So what does that mean? That means we're going 2 miles per hour, right? That is my unit rate. That point right there. Do you see that point right there? 1, 2. That means I'm going 2 miles every hour. What's this next point right here? 2, 4, right? I went 4 miles in 2 hours, right? I would go 6 miles in 3 hours. I would go 8 miles in 4 hours. So slope gives you the unit rate. Slope gives you the unit rate. And if it's a proportional relationship, that point right there, that y value, will be the same. So remember, slope we said was change in y over change in x. All right, and the letter we use is m. But for a proportional relationship, I'm just going to abbreviate that. For a proportional relationship, oh my goodness, Mr. Reeves, relate. All right. I'm just going to leave that. It's the same as y over x, which is k, right? Okay, so in a slope is always change in y over change in x. But for a proportional relationship, slope is also y over x, which is k, and those are going to always give you the unit rate. The unit rate. All right, we're almost done here. Last thing, let's take a look example at Scott hiking and Rebecca hiking. All right, and as you can see, just looking at those graphs, do you see how the scale is the same? All right, since the graph has the same scale, I can look right now and tell you who's going faster, and you should be able to tell me who's going faster. Rebecca is going faster because her line is steeper. It has a steeper slope. Therefore, she has a faster unit rate. She is going faster. In fact, if we take a look at the slope of this one, again, we're looking for points that are on the line and on the grid. There's a point right there. How much did I go up? I went up 1, 2, 3, and over 1, 2, 3, 4, 5. So the slope is 3/5. All right. So what does that mean? That means Scott is hiking 3/5 of a mile per hour. If you take a look, what did he do? He went 3 miles in 5 hours. All right. Do you see that? He went 3 miles. There's 3 miles. 3 miles is how far he went in 5 hours. So this would be, again, this would be a rate. But for the unit rate, we want to know how far he goes in 1 right there. That point right there would be 1 3/5. He goes 3/5 of a mile in 1 hour. So be careful between a rate and a unit rate. If I said true or false, he goes 3 miles in 5 hours, that would be true. If I said true or false, he goes 3/5 of a mile in 1 hour, that would be true. But only the unit rate has that second one as 1. So if that's for unit rate, they want to know how far does he go when x is 1. How far does he go when x is 1? That's the unit rate. All right, now if you take a look at Rebecca, if we go when x is 1, look, she's way up here when x is 1, right? So if we find the slope of her line, excuse me, I did not mean to scribble. Again, we're looking for points on the line and on the grid. It sure looks like that point's there, right? But if I go up 2 and over 1 again, can you see that I'm not there, right? So we need to be, sorry, my eraser's not working. We need to be super careful as we're looking at these points to find a point that's on the line and on the grid. That one sure looks like it, right? Up 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1, 2, 3, 4. All right, so it looks to me like that's what we want, because if we do any other one, again, over 2, up 2 over 1, if I go up 2 over 1, up 2 over 1, every time I'm getting further away. So I'm going to go with this point right here. So again, it was up, there's 5, 6, 7, 8, 9, and over 1, 2, 3, 4. So 9/4. All right, now I am not going to write, do not ever, ever, ever write slope as a mixed number. All right, if the directions say to write it as a simplified fraction, 9/4 is simplified. If you put 2 and 1/4, that is not simplified. That is a mixed number. And we never, ever, 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 ever write slope as a mixed number. Okay? Decimals sometimes, mixed numbers never. Never, ever, ever write slope as a mixed number. Okay? So simplified does not mean mixed number. I have students ask me that. Do you want me to write it? Do you want me to simplify it to a mixed number? No, that's not simplifying. That's changing the form. So the unit rate would be 9/4 of a mile per hour. Now again, I could say Rebecca hikes 9 miles in 4 hours, right? And if I said, how long would it, or how far would she go in 8 hours? Well, in 8 hours, she would go 18 miles, right? 18 miles in 8 hours, because we could just double it. But the unit rate is how far does she go in 1 hour? How far would she go? All right. And 9/4, as we just said, we didn't, is 2 1/4. Do you see right there? There's 2 right there. So 2 1/4, 2 1/4 miles every hour. All right. You could write that. After just saying you don't write the slope like that, you could write it for the unit rate. Okay, 2 1/4 mile per hour, or 2.25 miles per hour. And if we go back over, you could see the unit rate for Scott. He's only going 3/5 or 0.6 miles per hour. So do you see how much faster Rebecca is going? And in fact, if we were to graph these on the same line here, all right, we need to go up 3 and over 5 for Scott, right? Up 3 and over 1, 2, 3, 4, 5. All right, so that would be Scott's line right there. All right, so you can see Rebecca's slope is much greater than Scott's slope. So that means she has a greater unit rate. That means she is going faster. All right, and if you were asked to find points, all right, sometimes it helps to write these out as ordered pairs. So 3, 5 as an ordered pair, that would be 5, 3, right? So if I wanted to know what's next, well, I could double it and I could say 10, 6 or 15, 9, right? This is kind of like making a table. This one's going to go up by 5s and this one's going to go up by 3s, right? If we took a look at Scott's, right, what do we have here? His point was it went up 9 and over 4, so his point was 4, 9, right? So 4, 9, we could go 8, 18, we could go 12, 27. See how his x's go up by 4s and his y's go up by 9s. All right. Okay, well, I hope that was a good review for you. Again, if you need more of a review, go back and rewatch the videos, because I have a video on each of these, or multiple videos on each of those separately. All right, but I hope this helps you out. Until next time.